iPhone 1 to 3GS. When Steve Jobs first introduced the iPhone in 2007, he famously said, "Apple is going to reinvent the phone." And they did. But the real genius wasn't just combining a phone, an iPod, and an internet communicator. It was the science of the screen. Before the iPhone, phones either used a stylus or a resistive touchscreen. Resistive screens worked by having two layers of conductive material separated by tiny spacers. When you pushed down, the layers touched, completing a circuit that told the phone where you pressed. The problem? They were mushy, required pressure, and were absolutely terrible for multiple simultaneous touches. Forget about pinch to zoom. The iPhone introduced the capacitive touch screen. Instead of pressure, the iPhone screen had a grid of transparent conductive material. Your finger, which conducts electricity, acts as a temporary capacitor when it touches the glass. This slight change in the localized electrical field is registered by the grid's circuitry. Critically, it could track multiple distinct changes at once. This single engineering choice, moving from resistive to capacitive, was the scientific foundation for the next decade of smartphone interaction. It wasn't just a gadget, it was a revolution in human-computer interface. The 3G model, 2008, brought in GPS and the App Store, transforming the phone from a device into a computing platform. The 3GS, 2009, then doubled down on speed, introducing video recording and paving the way for the internal horsepower needed for complex apps. iPhone 4 to 6S. If the first generation was about the touch, the second era was about vision and power. When the iPhone 4 arrived in 2010, the design radically shifted to a flat, stainless steel band and two slabs of glass. But the key innovation was the Retina display. Apple doubled the pixel density, the number of individual light points, or pixels, per inch, to over 300. The claim, backed by human perception science, was that at a normal viewing distance, the human eye couldn't distinguish individual pixels. This wasn't just a marketing term. It was a calibrated approach to image resolution, setting a new benchmark for display clarity. Hidden inside the iPhone 4 was another critical shift, the Apple A-series chip. Before this, Apple used processors designed by others. By designing their own silicon, they could perfectly optimize the processor for iOS, gaining a huge leap in performance and efficiency. This decision is why iPhones maintain such high speeds and battery life compared to many competitors. It's a hardware-software marriage only possible through custom-designed chips. The iPhone 5, 2012, marked a major material change, shifting to an all-aluminum enclosure to get thinner and lighter, while the 5S, 2013, introduced Touch ID, a fingerprint sensor based on the science of capacitance mapping. It didn't just read the surface of your finger, it read the subepidermal layer, creating a high-resolution, unforgeable map of your print. It was the first time serious biometric security became mainstream. The iPhone 6 era, 2014, gave us the size changes, but the 6S introduced 3D Touch, which was a force sensor integrated into the backlight. It allowed the screen to measure the pressure of your touch, adding a third dimension of interaction to the 2D plane of the screen. iPhone 7 to 11 Pro. The most fascinating evolution of the iPhone happens right around the iPhone 7, where the hardware started to plateau and the software took over. The iPhone 7 Plus 2016 was the first to feature a dual camera system, a wide lens and a telephoto lens. This setup wasn't just for zoom, it was the mechanism for portrait mode. The two cameras captured images with a slight difference in perspective, allowing the phone's processor to calculate the depth map, the distance of every object in the frame. That depth map, an invisible layer of data, allowed the software to isolate the foreground subject and artificially apply the famous beautiful bokeh blur to the background. This wasn't optics, this was computational photography. The revolutionary iPhone X, 2017, eliminated the home button, marking a return to the original's all-screen philosophy. Its breakthrough was Face ID. The TrueDepth camera system projects over 30,000 invisible infrared dots onto your face, creating a 3D topographic map. This map is used for authentication, and the depth data is also what enabled sophisticated features like Animoji. It was the moment the phone gained the ability to truly see in 3D. With the iPhone 11 Pro 2019, the camera systems escalated to 3 lenses: wide, ultra-wide, telephoto. This was necessary for the spectacular night mode. Night mode works by quickly taking dozens of photos, aligning them perfectly, analyzing the noise or visual static, and combining them into a single, clean, bright image. The A-series chip, now featuring a dedicated neural engine, executes trillions of operations to make a photo taken in the dark look like it was taken at dusk. iPhone 12 to today. We are now in the era of refinement, where the changes are less about the screen and more about the invisible architecture and material science. The iPhone 12 Pro 2020 brought LiDAR, light detection and ranging, to the rear camera system. It shoots a laser and measures the time it takes for the light to bounce back, instantly creating a precise depth map of the environment. This vastly improves low-light photography autofocus, and more critically, enables incredibly accurate augmented reality, AR, blurring the line between your physical world and digital overlays. Most recently, with the latest generations, we are seeing breakthroughs in material science. Ceramic shield. The new front cover glass is infused with nanocrystalline ceramics, think super tiny ceramic particles, that make the glass 4 times tougher against drops. USB-C and titanium. The shift to USB-C was a regulatory one, but the new Pro model's adoption of titanium is a feat of engineering. Titanium is notoriously difficult to machine and finish, but its incredible strength-to-weight ratio allows for phones that are lighter, stronger, and more resistant to corrosion. The dynamic island. This isn't hardware, it's a brilliant software trick. It uses the cutout for the true depth camera and blends it seamlessly into iOS animations, transforming a hardware necessity, the camera housing, into a fluid, responsive software feature. From the simple magic of the capacitive touchscreen to the complex neural networks that power its cameras, the iPhone's history is a story of continuous iteration, a testament to how relentless, focused engineering can turn a basic concept into a global technological phenomenon. It's not just a phone, it's a living museum of applied science.